show on the road.
Yeah.
Let me see. Where am I? Where am I? Okay. And then where's my thing? Is it over here? Yes, sir. All right. Let me just go ahead and get my stuff set up. Today we're gonna do. All right. Okay. By the way, is your preferred language Python?
Yeah, Python.
All right. Okay. Sounds good. Oh, by the way, have you watched the interviews before, like the mock interviews before?
Yeah, I've seen a few. It's like,
All right. All right. So let's just keep this quick. So 1 hour session. We're gonna work about 45 minutes or so. All right, and we'll see how it goes. But I'll be aiming for about two problems. If you're fast, we can maybe do
yeah.
more, and then we'll have time for feedback at the end. All right.
Okay, yeah.
Okay. So the first question I'm going to ask, here you can just delete this. So the first question I'm going to ask you is a question called majority element. All right. So I want you to write me a function that takes in a list of integers, list of numbers, list of integers. All right, and then at least one element here, or sorry, one element here will appear at more like a majority of the time, like more than half the time. All right, and I want you to return that number, that element.
All right, so we can just start by making our function, passing a array, I guess. And so if we want to get the majority element, we probably want to get the element that has like the highest count, right? So we can have a count with the hash map here. So we can say our count is hash map. We can go through our array for I in array. We can then just initialize the count for the I. Now we'll have a count of each element in the array. So if we have like 2, 2, 1, 0 or something, we'd have like two count of two for the each, and like one for like one and one for the 0. So what we can do is then just take this count and just go and find the majority one.
Okay.
We're going to be looping through the each count and each number and its count. And is there a the majority is just the one that appears the most, right? So
Yes.
we can say that we just have a. Is there like a would there be like a tiebreaker here or like
No, there can't be a tiebreaker because you can't tie one element that appears more than half the time.
oh, the majority just appears more than half the time,
Yeah.
and it's
Or more.
always
Yeah.
there's always going to be majority.
There's always going to be a majority. Yeah. There's always going to be one.
So then we can say I guess the count of the majority would just be like the length of the array over two. I guess we can say majority would be length or if you say that r if n if the count of our if the count of our number is greater than uh, so if we say our count is greater our count of our number is greater than our length that you need to be the majority, then we can say that what's our we're looking to return the majority element, right?
Yes.
So return our count or our number that's the majority. And since it's always guaranteed to exist, I think this is it, right?
Okay. Can you tell me the current time and space complexity of this function?
So the time complexity of this would be O of n time complexity because you just do one pass with the for loop going through each letter. I mean going through each number and putting in the hash map and then accessing it, and the thing for and then going through each element in the hash map would also be O of n since you're just going through each of the counter items, which would be also O of n. So the overall time complexity would be O of n here.
Okay. And yeah, and then the space.
Space would be O of n here as well because you're using a hash map to or the each of the numbers mapped to its count.
Okay. Now I noticed that you are actually making two passes, right? So your first pass goes to the array, and your second pass goes through your frequency or your count. So I would like you to actually only make one pass in total.
Right, yeah. So to get it in one pass, I'd say we can I guess we could have like a running so for we have our counts here. We have two and like two and like one. One pass, I say we could. We just put like a nested loop here, but wait.
So think about your return criteria before, right? When would you return?
Okay, so we want to return when we find an element that has a majority count. We could just return once we find if one of our counts is indeed greater than if count of I is indeed greater than our majority. So we could say that the length would be R over 2. Right, so if we ever find a count that's greater than our length, then we can just return this I. Right?
Yep, okay.
So we're just looking for.
All right, so yeah, that sounds good to me. Does the time or space complexity change?
I don't think that it changed because you still just use a hash map to store each pair.
Okay.
With the and you still just loop through each element in the array once with the for loop.
Yeah. Yeah. Okay. All right. Sounds good. I would like to move to a second problem. So let's just keep this here and just leave it here for now. So I would like you to now write me a new function. This is a different problem now. It's not related. So in this problem, I would like you to write me a function which takes in a list of integers that is sorted in increasing order. And then I would like you to remove all the duplicates in this list.
List of integers in increasing order function that removes all duplicates in this. Is this going to be in place?
Yes, it's going to be in place.
There's no return value, it's just in place.
Okay. Yeah. Let's just do that for now. Yeah.
So first, you can say let function remove pass in our list. So let's first we can just like draw out duplicates. So in order to remove the duplicates from this list, I'd say have like a pointer here, I guess. You could have a left pointer. And then we could also have like a this list is sorted, right?
Yes, the list is supposed to be sorted.
So like 1, 2, 3, 4. So when you mean remove, like, are you like just deleting it from the list, or just want to like make a new list that
Like you delete it so that there's no more duplicates in the list. Yeah.
and you can't do it with the can't make like a new array as well and just like return that, or
Oh, there's no return. I mean, there's no return value for this place. I mean, let's just pretend it's an in place operation.
can you like clarify that? So you want to like
There's no return value here, so you just want to set array to be equal to, in this like you want it to be eventually be 1, 2, 3, 4, right?
yeah.
Yeah. So you remove one of the 2's from the array.
Okay. And it just be like straight up remove.
Yeah, you're removing all the duplicates in the list.
Okay. Since this is in a sorted order, I guess you could check the adjacent pairs for duplicates. So have a left pointer at 0. Is there like a minimum length of this array? Can it be like just one character? Actually, never mind.
It could be 1.
Okay. So we can go through each element in the array. Here, if there are any adjacent pairs. So if you're going through 1, 2, 2, 3, 4, you'd say where R pointer. You start your R pointer here. And then you check, okay, is this previous one a duplicate? And if it's not, you just move it up. If you do find a duplicate with your previous R, I'd say we can. Could you just do? I'm worried this would like cause like an index error when you're like. You could just delete this number, I guess.
Yeah, and under what circumstance would you update the left pointer?
The left pointer. Yeah, I don't think the left pointer will be getting used here.
Okay.
Say that. It's the remove by the index of. Say we remove the previous one. Let's see. Is the remove function by the index, or is this
The remove function is by value.
by? Say this remove. remove the previous adjacent value.
What is R is an index though, right? So you're using the index, so this is how you get the value. Is that the purpose? If you
I
want to
think
remove at
so.
an index, you can use delete, which I think
Right,
the
delete,
syntax
yeah.
is like.
And delete. Say that remove the you just go through each one if you ever get like a uh I feel like this would have like a issue with like the index going like out of bounds, like the for loop.
Okay, can you explain why?
Uh, when you like delete it like I'm pretty sure it would like update like the how many elements are still in the array. So then, but this loop would still be going to the original length of the array, which would be like it would be like a length 5 here. But now your not thing would now be 4, and then so now it would like go out of bounds eventually.
Right. So you can't use a range like this then, because this is always going to go to 5.
Yeah.
So what else could you do? In this case, you can't use a for loop for a range because a range is pre-computed when
Say
the
we could
when the
use
for
like
loop
a
is initialized. So you
while
can't use a
loop
for
here.
loop. You need to use a different type of loop.
Use a while loop here. I guess we could say that there we go. I could say like a function for like while there's no duplicates in the
You could do that, but
they
you
would
you
have
already
a
have an
function.
R pointer.
Yeah. This is probably gonna be inefficient because they make like a helper function that has like checks each time if there's any duplicates.
Okay.
You choose a set. This would be return true or false if the array still has duplicates.
Okay.
So while has duplicates, you pass in your array. Wait, yeah, here is gonna be while it's true. So now when you go do your left R and left and you do your R pointer here. And say that we go with our R pointer and we find a duplicate. Can we like do the remove here? But now we need like the pointers and everything. So you said R is gonna be 0. Yeah, we just have to say R is 1 here. So if we do find a duplicate, then we just keep incrementing R each time. And so if we delete so let's we're on where R would be on index 2, right? And we delete the previous one. And our R would go to now our R would be on a whole other it would be on index 3, which would be not it would be here. So you want to subtract 1 from your R, I think.
Okay, yeah.
Like balance out the fact that you deleted the
Yeah.
R here.
Okay, yeah.
So this function checks if it's this, and then this should like end when there are no more duplicates, I think, and then
Okay. Are you done, or are you still looking?
I think I'd say I'm done.
Okay. Then can we do the time and space, please?
I'd say so. I'd say the time and space of this is it would be for this has duplicates function. Each time you have to go to the full array each time, so that'd be O of n time complexity. And for this while loop here, you go through each element in the array each time as well. That'd be also O of n. And I assume each iteration of the while loop is calling the has duplicates function. So it'd be O of n for this part here and O of n for this part for looping through the full array. So that'd be n squared here. And I'd say my space complexity here, since we're using a set, would be it would be O of n.
Okay. Okay. Let's try to improve this.
Wait.
Right. We should be able to improve this. You know, if you think about it, if we're trying to, like, the first thing I think we want to look at is what's going on with this condition.
Yeah.
Right. So can you tell me what is the purpose of the has duplicates helper?
That with the has duplicates helper is just checking if there's if the array has any duplicates. So what that's checking is that if any number has a count of greater than 1 and it has a duplicate.
Yes. And the reason we're doing that is because we want to know whether or not we still need a loop or not. That's the actual purpose. Yeah. So let's look at our pointer. Right, we have an R pointer. And the key thing to know about this R pointer, it's a very special pointer because it has an invariant. Okay? The invariant with this pointer is that everything to the left of the R pointer has no duplicates. Right? Do you understand that?
I think I see that.
Right? Because if it had a duplicate, it would have got deleted. So by the time we advance the R pointer, right, we can say that everything to the left of the R pointer is unique. Sorry, not, well, yeah, has no duplicate / unique. Right? This is what we call an invariant. Right? And and what's the goal? Right? The goal is to remove all the duplicates in the entire array. Right? In other words, if our R pointer is at the last element,
so then we know everything is removed already.
Well, then we know everything to the left of the pointer is not a duplicate. But then you might do one more check. right? So I want you to think about it a little bit more, and to use this invariant, the property I just described to you, in place of the has duplicate function. Okay? So have a thought about that one. See what you come up with.
So looking at this, we'd say, so if we look at our invariant of everything before R having no duplicates, since we would have already removed it, right?
Yes.
So if we move up R, then okay, so we know that everything before here has no duplicates. I'm gonna remove this one. And then where R is, we know that everything before R has no duplicates since we would have removed it. So there'd be like maybe there could potentially be like a so we want to replace this has duplicates function. We don't want to we just like we just need a while condition that can we just do until the R is until the end of the array since wait, no, then you have to use the pre-computed len again.
Yeah, you could do that.
So R is less than. Count here of like R with a hash map that and we get so if we go through if you have your R here then so every time you delete you just like -1 from the count right and then so if you ever have like if you ever wait never mind that would if you had like a duplicate here then that would like probably end the loop because you would probably say that
What's the purpose of count here?
I was kind of confusing this with like a sliding window, but I don't think the count would work here because
Can we use like the condition being R less than the length of array here? Or less than array plus 1, depending on what you're trying to do exactly? Can we do that? Is that possible as a condition?
if we do R is less than so let's say our starting array length is 5 here, right?
Yeah.
We're gonna move our R up until we get a duplicate. So right now 0, 1, 2, 3. So R is on index 3, right?
Yeah.
So we're gonna I don't know, we found a duplicate here. So R is on the last index right now. It's on index 4. So we're just gonna remove this. Now our length would be 3 of our array. So we're gonna move around -1 R again. So this would remove it, but we just need to I think R won't go out of bounds, so I think just while R is like just while true, and if you ever hit the length of like the end, if len of R equal to R -1, like a it's true. Oh, and if R ever hits the end of the array, then you know it's everything past its duplicate. You can just end here. So we can say that end is false. Right?
So when your R is over here, your length of array is 4, and your R is 3.
Oh, yeah.
So is 4 equal to 2?
Let me try to see what my R pointer is doing. So if my R pointer is at 0, 1, 2. So if my R pointer was 0, 1, 2, 3, 4, right? Then I delete the one before. So right now my length of this array is 4. 0, 1, 2 is 4 right now, right?
Yeah, it's 4. Length is 4.
And my R pointer was on just on 0, 1, 2, 3, 4, so index 4. And now we just minus that to index 3. Then you add it here again. Now it's index 4 again. It's still here.
Okay.
Let me see how that works for like if it's not at the very end. See like R is go up R, you have 0, 1, 2, 3. So you found your duplicate here. Now you wanna remove this index. So your length is 5. So now your length should be 4. Your R is currently on index 0, 1, 2, 3. So you're gonna remove your R. You're gonna subtract 1 from the R. It's gonna be on index 3. It's gonna go to index 2, and then you're gonna move it up again to index 3. 0, 1, 2, 3. Right. So if we want to check that the R had the length of the array has reached the very last one, we could say that so this length of our array that we're computing here would now be 4. We want to check if it's R. So I know it's R, but R is 0, 1, 2, 3. You know, where wasn't our R just on index 4? Right. So we're at 0, 1, 2, 3. So we're gonna subtract, delete this one, subtract 1 from R. So R was on index 3, so it's 0, 1, 2, 3. And now it's going to be on index 2. Now it's going to go back to index 3. All right, so I'd say it's just R, right? Because R does get 0, 1, 2, 3. All right, I think this is it.
Okay. So let's assume this is correct, and then I would like to discuss the time and space again.
Okay. I guess. So the time and space of this would just be it would go through 1, 2, 3, 4 in one pass, so that would be of n here. And space complexity would be of 1 since you don't have any you're not storing anything, you're just yeah. I think deletion is deletion an O of n operation.
Deletion is an open operation, yeah.
So you'd be going through each single one with the while loop, right? With your R pointer. But you'd also be deleting. But then to delete, you'd also be going through each single one again. So this might be O n squared operation. Is it? I don't think the delete would be the full. I don't think you're going through the full array each time, so I think you could say it's O of n.
Okay. So you're still saying O squared, n squared, I mean?
I'll say it's n. Yeah, I'd say it's n squared.
Okay. And then the time?
You mean the space, right?
Sorry, yeah, the space.
Yeah, so space will just be O of 1 because you're not storing anything here. You're just
Yes, okay. All right. We have about 10 minutes, so I think I actually want to move on to a third problem.
okay.
So this is going to be an unrelated problem again, and this is a bit of a classic one. It's called valid parentheses. I'm not sure if you've heard of it, but let's give this one a go.
Okay, yeah.
All right. So for this problem, you're gonna write a function that takes in a string, and the string will contain only the characters that are related to parentheses. So that's these characters over here.
Only. Yeah, so I get the parentheses characters. Great.
Yep. And then you are going to return true if and only if the string is valid. And I will paste in the condition for valid over here. There are 3 conditions, and they must all be met.
So this means like the open brackets must be closed by. So there must be like a matching pair for like each.
There must be a
open
matching
bracket.
pair, and the closing order must also match.
Right. So every closed bracket has. You can't have like a open bracket and then have like a. Like yeah, you can't have like a. Yeah, you can't have like this. Right. You just have like the correct order.
That's right, yeah. It has to be the correct order, so that would be invalid.
So what we could do here is then have like a stack here. So we could have a stack to store the parentheses. So you could have like a since you want to have the correct order here, every time you get a correct parentheses match, you know, let's say you get this correct parentheses match, then you want to pop this from your stack, right?
Yeah.
Then at the end of the going through each bracket in the string, if your stack is empty, then you know you've popped every valid pair. And you could check with the valid pairs by checking if the top of your stack is. You can start by having a hash map with each of the closing parentheses. Start with the closing parentheses. And then you can check if the top of the stack would be the matching open one. And then if you have that match, then you can just pop this from your stack. And then at the end of after going through each of your brackets, then you can just check if your stack is empty, then you've popped everything, and then you know everything in there is valid. And if it's not empty, then you know that you still have like some like bad pairs that were not able to be fully popped. So
Yeah, that sounds right.
Make your stack here. First we can like map to be able to have the to be able to see if the when you're looping through the closing parentheses and you want to see if there's like matching open one, you could have like a hash map that maps each closing to its open. So you could easily like check that in O of 1. We could first have our hash map. You could say close to open. Right, we just have our closing parenthesis here. Map is to our the open, and do this for each of them. closing, and map this to our open. Same for the curly one. So you have the closing, map this to our open. Right, so this will be our hash map here. And you know, you can have a stack where you put your each of your brackets in your string. So now you can go through each. Oh, you should make a function though, right? You're passing a string, so def valid, and you pass in your string. Now you can go through each bracket in your string. So you can go for I in your string. So now you can so now this so you want to pop off the matches, right? So you want to pop the matches. So you're gonna want to check if this I you're going through is okay, and you pop a match when you have a matching closing parentheses with this a matching open parentheses. So you want to check if this is if I here is a closing parentheses, and since you have a hash map of all the closing parentheses, you can just check if I is in your closing hash map here. And then when you check if it's a closing parentheses, okay, now since we're going to be placing each one on our stack, we want to check, okay, if the top of our stack is the matching open parentheses, so we can check if the top of our stack is equal to our hash map with our closing parentheses map to, so it'll be I, since I is our, since if we know that I is closing here, it's a closing parent, right? So the CTOI would just be our matching open. So if we have that, then we can say that, okay, so we have a match here. So we can just do stack.pop. And otherwise, if we don't have a match, then we know we have like we have like a mismatch, so we can just return. We want to return true or false, right?
Yeah.
You say return false. Then otherwise, if we have a so otherwise, if it's not in our close to open hash map, then we can say it's an open parentheses. It'll be an open parentheses. It's an open parentheses. Right, so we can just add to our, if it's an open parentheses, we can keep adding open parentheses, like it'll be like you can keep adding open parentheses as long as you like eventually close them, right? So you can like keep adding them, but you just have to eventually close. So you could just add the open parentheses, keep adding them to the stack. Then we just check if not stack. So this means the stack is empty. We just return true. Otherwise, if it's not empty, we need to return false. And yeah, I think this is it.
Okay. So what if your input is this?
If it's just it's a single closing parentheses. Go to this. So it's inner thing. You should probably check if the stack is not empty here. But our stack is. We check, so this wouldn't run if our stack is not empty. So right now our stack is empty. So else, if we just stack append. So right, so this would just run as if our i's and our brackets, which it is, and then this would be our else condition here. It would just return false because.
Yep, sounds good. What's the time and space?
This would be O of n time. The time complexity of this would be O of n because your string of parentheses, you just do one pass with your for loop, and you just check each single string at most once. So that would be O of n time complexity, and your space complexity would be O of n because you just store at most in your stack and your hash map, which would both be O of n each. So that would be O for total time space complexity would just also be O of n.
Yep. Okay. Let's quickly write that down. You said in for both, right? Okay, that sounds good to me. We're at time, so I'm gonna end the mock here, and we'll go to the feedback now. Usually, I like to ask, just for you to start, how did you feel about the interview today?
I think it went like okay, except for the second question, the list of integers in increasing order. I feel like I messed this one up.
What about it did you mess up?
I just feel like I was like stumbling on like the delete and like remove and like also like the index.
Okay. But how do the other two questions go?
I think the majority element one, I think it went well. I think I was like okay with the explanation there. And then for the valid parentheses, I think it went okay as well. I feel like I was able to explain like a good bit of it. But I think pretty sure I have like seen this like a while ago. It wasn't like fresh off my head, but like.
Yeah. Okay. Yeah. Let's just quickly talk about the first and last questions, and then we can spend a bit more time on the middle one. So
Right, yeah.
the majority element one, this is a pretty. I think the way I would phrase this is pretty good intuition with the frequency. I think that was quite well done. Um, I think for clarification purposes, you probably should have spent a bit more time on like the the problem description and definition. And the reason
Right,
I
yeah.
say this is because like in your example, this example is invalid because it has no majority element. And the other
Okay.
part is I would say you should like generally speaking, it's okay if you want to like be a bit inefficient as long as the time complexity is the same, which is what we had previously. But if you see there is a way to have a pretty easy optimization, you should call it out, right? Even if like you don't want to implement it or you think it's going to cost a lot of time, you should at least say, hey, I'm aware that we could do this one pass. Would you like me to pursue that option as well? So that's an area where you can get a couple free points, right? So just be aware that these patterns are pretty common, right? Like when you think about it, when you have some state you're maintaining, and then you want to have some exit condition based on the state. Like especially if you can short circuit, like in this case, right? That's going to help your performance on average. So that's good to call out if you can see that ahead of time, right?
Right, yeah.
Question 3 wise. So here's the thing about valid parentheses is that everybody knows that everybody's seen it. So the standard isn't does your solution work, it's how well does it work. Okay. So things like missing edge cases is more difficult to explain because that is more of the problem per se, right? Like everybody knows what the algorithm should roughly be, but people want to say, okay, well, how good are you actually implementing it? Are you good at catching these edge cases? Are you good at voicing through these examples? So this is a common thing I'll see, which is, hey, after you're done the problem, I want you to go through and to think to yourself, what are some more difficult or tricky cases that can come up, right? It's a lot better for you to think of that yourself than to be prompted about it later on.
Yeah. So I should like just like do that on my own and like think about edge cases on my own.
You should be calling it out. Say, hey, I'm done the solution, but I would like to run through some more of these edge cases ahead of time. Or if better yet, if you have the time to spare, you should do that before starting the problem, right? Like when you're clarifying the requirements, clarifying the inputs. That's when you should be calling out. Oh, hey, here are some edge cases I anticipate, right? How are we going to handle those?
Yeah.
So yeah, just be aware of that. Um, well, I was gonna say no. That's fine. Yeah, otherwise it's fine. Okay, and then let's talk about remove. This remove duplicates function. So this is a problem that it's relatively simple to implement, which you have done, but there seemed to be something which tripped you up in this case. And I don't quite know what it is that tripped you up, but I anticipate this might be a general thing that you need to practice more with pointers. Right? Just getting some more experience playing around with different pointer problems, getting some experience playing around with, checking exit conditions. Right? And here's the thing about this problem is that you actually had a pretty good understanding at the very start about how, using the range is not going to be valid because you will be out of the range if you start deleting elements. Now, I did give you a hint to use, instead of using a for x in range or for index in range, to use a while. And the reason is because the while condition is evaluated at every iteration, right? And when you're using helpers in Python like range, it obfuscates what happens. So the for, by the way, the for condition is also evaluated at every iteration, but the condition itself doesn't change, right? So keep this in mind. So for example, right, if we had like for I in range, you had what? I guess it was land array. Right, this basically says for I in 0, 1, 2, 3, 4. Right? So what happens is this condition is evaluated at every iteration, which is what you would expect, but the condition itself doesn't change, when in reality you wanted this to be like over here, for example, right? So keep that in mind as a difference. Now, and the reason I say this because this is an example of a Python like convenience. Like this makes your life easier most of the time, but you need to understand limitations, right? Well, for example, if you had just done while I less than len array, right? This length of array changes at every iteration because you delete elements.
Yeah, yeah, that'd be the difference between the while and the for.
Yes, and that's a difference, right?
Yeah.
So keep that in mind. Couple things about indexes to kind of play around with more on your side. So I would encourage you to play around with. And when you call it out, there's 2-pointer problems. There's sliding window problems. Those are all good for practicing, right? So I would recommend you get on that. And the other thing I'll say is that, overall, I think the time and space complexity analysis was quite strong across the board. There was a little hiccup with you asking about the deletion of an index in an array. That is something you're probably not familiar with, so you just go brush up on these kind of things, right? But I think overall your reasoning for complexity for both time and space was quite strong, so I think that's a strong suit here. All right, let me just quickly take a look. Anything else I wanted to say? Oh yeah, one more thing I did want to say was that technically speaking, when I originally said that this function, the input to your remove, it contains at least one element, but you are assuming it contains 2, with your right pointer starting at index 1, which is also technically invalid. So these are the kind of things that you should be clarifying and make sure you get kind of down. And I think you actually asked about that, or maybe I just volunteered the information, but like these are the kind of things that you just want to make sure you have down pat. So just keep that in mind. And I did actually point out my notes that technically speaking, this would have still been valid if you were using the duplicates helper, because this would have returned false. So you would have been saved by that inefficiency, although that's obviously not ideal. But that's kind of my notes. I'll send you my detailed notes later on. You can have a look. But last 5 minutes here, I want to give you the opportunity to ask any questions you had.
Right. Yeah. Would you say like I should be like asking, like trying to get like before I start the problem, like just be like very clear on like ask like clarifying questions on like before starting problems?
Yeah, I would say so. In particular, it probably would have saved you a bit of time on the remove, and it likely would have saved you a bit of time on majority, although I don't know how true that would be. But the important part is that it's not really just about how well you perform in the short term. Like the easy kind of questions, you can kind of just breeze through and just kind of do whatever. It's all going to be okay. But once you get into the more and more difficult problems, the time investment up front is more and more important because you can't afford to backtrack later on. So I think it's an important habit to get into to kind of prepare yourself for the more difficult problems.
Yeah. And you said, yeah, I should be like very like I should like so whenever I like feel like I've completed a problem, I should be like okay, then I should like go on my own to like discuss the edge cases and stuff.
Some problems lend themselves more to edge cases. Like for example, valid parens has a lot of edge cases. So that one I would recommend you absolutely do so. And in fact, I would recommend you to highlight the edge cases ahead, like before you even start implementing the function, just to highlight that these are the test cases that you will run through as a check. And then for problems like remove duplicate and majority, they don't really have edge cases. Most easy problems don't really have edge cases. So for those ones, you might want to just call out what I call the generic edge cases, like edge cases based solely on the type, right? For example, remove is an array or a list of integers, right? So the edge cases there are, okay, what if the edge case, what if the list is none? What if it's empty, right? So those are the kind of things you would talk about. But like in terms of logic, there's not going to be any logical edge cases like there are for valid parentheses. And most easy problems you run into will likely not have or have very few logical edge cases. Cool. Any other questions? Oh, did you drop from the call?
I don't think I have any more questions right now. I think I've yeah, I got that. I understand the feedback.
All right. Okay. In that case, then I'll end the interview here. Thanks for coming out, and I'll send the detailed notes later. Take care.
All right, yeah, thank you.
That's not some Discord connection issues there. Why am I not logged in? Anyways, we're doing resume reviews now after I get my Figma to work. Well, here we go. So if you get a problem on an interview that you already know and the interview knows that you've seen it, do you ask for a different problem or do you solve it and pretend you haven't seen it? You shouldn't pretend to not have seen it because most interviewers like myself can tell pretty easily, to be honest. Especially if you're going back to back with a problem that you haven't seen. So I would say, hey, I've seen this problem. Would you like to do another problem, or do you want me to solve it anyway? So just ask them. Most of the time, they'll just let you solve it anyways, and just they'll just account for the fact you've seen it. One thing that some students might not understand is that the actual solution to the problem is not much weight compared to everything else surrounding the problem itself. Like for example, your ability to communicate and to discuss and to justify your reasoning. Okay, where's my form? Forms dot, what is this? Forms. Okay. Resume reviews. it should be this one. All right. Let me copy one of my previous things. Oops. All right. See you guys in a bit. what are we doing? Okay, we got a submission. Let's take a look. All right. Only one submission today, so we probably got off early today. Nice. All right, so this guy's comment, break into Fang AI infra. Tell us for a global top 10 life sciences firm. What the hell is that? Okay. What does this mean? Develop scalable net Python microservices integrating ChatGPT with legacy data warehouses. Like these, I don't know. These points just feel like keyword slop. Like, okay, like what does this mean? So you develop some microservices, and these microservices integrate ChatGPT with Lego data warehouses. What does that mean? Achieving sub 200 millisecond latency. Latency for what? Latency for ChatGPT? Latency for you to call ChatGPT? Latency for ChatGPT? I feel like this is very ill-defined, and this, I don't know. This just feels like a lot of keywords here with no actual information to me. Okay, another one. Let's take a look at this one. Maybe this one's better. Okay. 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 I mean, sure. 3 months. I can buy that. Okay. Agentic RAG using Python on AI Foundry. Okay. You did a thing to reduce manual research time by 50%. Okay. First 2 points are fine. Third point's whack. Alright, so AI wise, this is a bit far off. A lot of what I'm looking at right now is looking at using AI to do things. The only exception that maybe is a thing is what engineered specifically means. This is a way overloaded term. I mean, look, I mean, you're obviously like more of a like a junior situation here, so I'm not gonna harp on this, right? But engineers too overloaded. This doesn't actually have any descriptive power. So AI roles is a bit far off. Infra roles I can see, right? You have some Azure, some pretty good stuff over here. You have what else I see? I saw this. This is pretty good, right? You have Terraform. Terraform's great. You have some more Azure stuff over here. I think infrastructure might be a better angle for this for the stuff going on here. So I think that's more realistic. Now for infra specifically, I think you have some good basics. Like these are good basics to have. If you have anything else you can play up a bit more, that like I think that would be worth putting on. And the thing about infra is that infra and AI are completely different. So if you feel like you had to cut points here and there for these purposes, I would recommend having two resumes. So have an AI one, and then have a separate infra one. Okay, no other resumes. I'm gonna give, I guess, 2 minutes for people to submit if you're in the middle of submitting something right now, or type in the chat so I know you're trying to do something. And and then I will head off. Playlist, boom. There we go, that should be cooking. Actually, never mind. What's next week? All right, let's take a look. No submissions, then we're done.